Welcome to GCSE Maths Help. Today we're going to be looking at compound measures exam paper questions. This video is a follow-on from my compound measures key points video, which I will link in the bio below. If you haven't watched that video, you might find it useful before looking at exam questions. For everyone else, let's get started. So our first question, we're looking at rates of interest. It says the value of a new car is £18,000. The value of the car decreases by 25% in the first year, 12% in each of the next 4 years. Work out the value of the car after 5 years. So in the first year, if the car decreased in value by a quarter, we need to find a quarter of £18,000 divided by 100 times 25 is equal to £4,500. So after the first year, the car is only worth £13,500. So now, because the next 4 years, the rate of depreciation is the same each year, we can use our formula. So we've got amount times 1 minus, because we're losing value, rate divided by 100 to the power of the time scale. So we've got £13,500 is our starting amount times 1 minus 12% divided by 100 to the power 4, because we're looking at 4 years. So if we put that into our calculator, the car is worth after 5 years £8,095 and 89 pence. So I've rounded this amount on the calculator to 2 decimal places because we're talking about money in this question. Our next question says Liam drives his car. He drives the first 9 miles in 9 minutes. He then drives at an average speed of 70 miles per hour for 1 hour 36 minutes. Use the information to show that his car uses less than 3 gallons of petrol for the drive. Now, this is one of these questions where we need to watch what measurements our figures are in, because in the question it talks about time in minutes, but the speed in the table says miles per hour, so we're going to have to convert minutes to hours. In order to work out how much petrol's been used, we need to work out the average speed for the different parts of his journey. So to begin with, he travels 9 miles in 9 minutes. So to work out the average speed, we need speed is equal to distance divided by time. So for the first part of his journey, he's done 9 miles in 0.15 hours, which is 9 minutes in terms of hours. So for that part of the journey, we've got a speed of 60 miles per hour. So for the second part of his journey, he's gone 70 miles per hour. So we don't know the distance, but we know he did it in 1.6 hours, which is 1 hour and 36 minutes in terms of hours. So if we times 70 miles per hour by 1.6 hours, the distance that he covered is 112 miles. So if we have a look at the miles travelled per gallon table, for the first part of the journey, he was under the 65 miles per hour section. So if you can do 50 miles with 1 gallon of petrol, he only did 9 miles. So we're dividing 50 by 5.5 to get to 9. So it only used 0.18 gallons of petrol. So for the second part of Liam's journey, he was travelling at 70 miles per hour. So that's in the other category. So more than 65 miles per hour, if you can do 40 miles on 1 gallon of petrol, Liam travelled 112 miles. So to get from 40 to 112, we times by 2.8. So we need to times 1 by 2.8 as well to give us 2.8 gallons of petrol. So if we add the two amounts of petrol together, we get 0.18 plus 2.8 gallons, which totals at 2.98 gallons of petrol. So indeed, his car did use less than 3 gallons of petrol for the drive. So our next question says the point 3, 1 over 64, lies on the curve y equals k to the power x, where k is a constant. Show that the point a half lies on the curve. So in order to find out if this coordinate is on the curve, we need to find out the equation of the line. So we need to find out what k is. So if we put in the coordinates that we know, we've got 1 over 64 is equal to k to the power 3. So if we cube root both sides, we get k is equal to 1/4. So our equation must be y is equal to 1/4 to the power x. So to see if the point a half is on the curve, we're going to put x equal to 1/2 and see what we get. So 1/4 to the power 1/2 on our calculators is 1/2. So this point must lie on the curve. So our last question says, Izzy runs an 80-metre race in 14 seconds. During the first 6 seconds, her speed increased at a constant rate. During the last 8 seconds, her speed increased at a different constant rate. Her speed at 14 seconds was 2 metres per second more than the speed at 6 seconds. Here is a sketch of her speed time graph. When Izzy finishes the 80-metre race, her speed is v metres per second. Work out the value of v. So in order to work out Izzy's speed, we need to do speed is equal to the distance divided by the time that she ran it in. So we can see the time on the graph, but the distance we don't know. So in the key points video, we learned that when we've got a speed time graph, we've got speed on the y-axis and time on the x-axis, we can work out the distance from calculating the area under the line. So I'm going to split this area into a triangle and a trapezium. So if we work out the area of the triangle and the trapezium, we can work out the distance for our speed calculation. So we know that when Izzy finished the race, her speed was v metres per second. So that must be the height of the graph at that point. We also know that her speed at 14 seconds was 2 metres per second more than her speed at 6 seconds. So the height of the graph at this point must be v minus 2. So we can use these values to help us work out the areas. So our area of the triangle is 1/2 times a height times the width. So we've got 1/2 times 6 times v minus 2 in brackets. So the area of a trapezium is 1/2 times a plus b times h. So we've got 1/2 times v minus 2 plus v, all in brackets, times 8 seconds. So we know that the area under the curve is going to be 3 v minus 2 plus the area of the trapezium, which is going to be 4 2v minus 2. So that multiplies out to make 3v minus 6 plus 8v minus 8. So we were told in the question that the race lasted 80 metres, so this area here must equal 80. So if we tidy that up, we've got 11v minus 14 is equal to 80. So if we add 14 to both sides, we get 11v is equal to 94. So then divide both sides by 11, we get v is equal to 8.54. So at the end of the race, Izzy's speed was 8.54 miles per second. I really hope you found this video helpful. If you would like to have a little recap on the key points on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching.